Hi guys. In my opinion, this is probably going to be the toughest section for your test. So it's going to be pretty normal if you have questions on this. You might need to set up a Google Meet to go over some of the homework questions. We're going to do the test review homework. That's going to be it for the rest of the chapter because we're really going to try to get ready to take that test by next week to beat the Thanksgiving break. So we're going to solve rational and radical equations. Rational are equations with fractions, and radical equations are equations with square roots or radicals in them. Okay, so that's what we're going to do. And first of all, what is a rational equation? They have fractions in them, and what you're going to do is what you're going to hate most about the problem is the fraction. So we're going to clear the fractions, and that's going to allow us to solve it like normal. It is really important that you must check on these. And the reason you have to check is because at the beginning of the problem, because these are fractions, you know that fractions have risk factors for domain issues. So what's going to happen, sometimes you're going to solve the problem right, and you're going to get what we call extraneous solutions, which are extra solutions. It means you got the answer right, but you did the math right, but the answer is wrong because it does not fit in the domain restrictions, and it just does not work. So you're going to be very careful when you solve these. Some of you are going to have a hard time clearing the fractions, and you're just going to have to, like I said, do a couple examples, and it will become a little bit easier for you. So here's the first example. And the reason that we would have to check for starters is we know that t cannot equal 0. So if I get an answer of t being 0, then I did something wrong because in all these pieces, that would be a domain restriction. So here's what we're going to do. We're going to multiply the whole entire thing by something to get rid of all these fractions. Well, what would get rid of this t, multiplying it by t? If I multiply by t, that one will go away. If I multiply by t here, will the whole fraction go away? No, the 2 also has to be multiplied by. So it's actually now a 2t. And now if I wanted to get rid of the 3t, I still would have to multiply by a 3. So 2 times 3, that's going to give me 6t. 6t is the least common denominator. Some of you would have seen that right away. And we're going to multiply all the pieces by 6t. And that's going to allow us to get rid of the fractions. Some of you will need to write it on the side. Some of you will have a hard time seeing what to do. Others of you will see right away. The t's are going to cancel here, and I'll just be left with 6. Those of you who couldn't see that, it's because if you multiply the tops and keep them on top, multiply the bottoms and keep them on bottom, it's 6t over t, and that simplifies to 6. Plus, the 6 and the 2 will cancel here, leaving me with a 3, and the t's will cancel, which will just be a 3. Again, if you couldn't see that, it would be 6t if you multiply the tops over 2t. Those t's cancel, and you're left with 3. 6t multiplied by the 1 over 3t, the 6 and the 3 would cancel, leaving me with a 2, and the t's would cancel, so that'd be a plus 2. Or you could think of it as 6t over 3t, the t's would cancel, and you're left with 2, equals 6t times 5, which is 30t. So this equation is way easier, right? So you just will add 3 plus 2 is 5, 5 plus 6 is 11. So 11 equals 30t, and you divide both sides by 30, and you get this weird fraction, but that's okay. T equals 11 over 30. You never would have got that by guessing and checking, but it's not. T is not illegal. T does not equal 0, so that is my final answer. Okay, how about this one? Okay, so this one's a little bit trickier. It doesn't look like there's any domain restrictions here because 3 and 2 will never turn into a 0, so this looks okay. And actually, this fraction is going to get pretty easy to get rid of because we can multiply everything by 3 to get rid of this guy and 2 to get rid of this guy. So we're just going to multiply everybody by 6. Now, this is where it gets a little bit tricky. So when I take 6 times this whole thing, the 6 divides with a 3, and that leaves me with a 2. You divide by what's on bottom, and you multiply by what's on top. So that leaves you with 2 times x minus 8. If you couldn't see that, multiply the tops, keep them on top. multiply the bottoms, keep them on bottom, and then you can simplify. 6 divided by 3 is 2 times the x minus 8. We'll distribute in a second. So same thing here, divide by what's on bottom, multiply by what's on top. So the 6 will divide into the 2, leaving me with a 3. This is a plus sign, but I still have to take it times the top, which is x minus 3, and 6 times 0 is 0. If you couldn't see that last one, it was 6 times x minus 3 all over 2. 6 divided by 2 is 3 times x minus 3. All right, now let's clean up. That's 2x minus 16 plus 3x minus 9, and that's going to equal 0. Oh, little glitch. 2x and 3x is 5x. Minus 16 minus 9 is minus 25. Add 25. Divide by 5. And you get x equals 5. This one's real easy to check. 5 minus 8, that's negative 3 over 3. 5 minus 3 is 2 over 2. Does that equal 0? Yeah, negative 1 plus 1 equals 0. So those are some rationals. Now, what do you do in a case like this? On a case like this, you can clear out the fraction by multiplying everybody by x minus 3. There is a domain restriction. X cannot equal what when I get an answer? Can't equal 3, right? Because that would give me 0 in the denominator. Now, there's 3 different choices you could do here. If you wanted to clear out the fractions, you can multiply everybody by x minus 3. And it will clear out both of them. And the reason it will clear out both of them is because the other thing you could have done is just set those equal to each other. Because the denominators are the same, the numerators have to be the same. X squared can just equal 9. Square root both sides. Don't forget your plus or minus, and you get plus or minus 3. Well, you can't have positive 3. So the answer is just negative 3. So that's one way you could do it. Another way you could have done it is this is a fraction equals a fraction. You could cross multiply, but that makes it a little bit trickier. I actually don't even know if we would cross multiply. X squared times x minus 3, because that's going to give me an x to the cube, equals 9 times x minus 3. Let's see what happens. That's x to the third minus 3x squared equals 9x minus 27. Yeah, so what's going to happen here is you would have to factor. They both have an x squared in common. That leaves you with an x minus 3. They both have a 9 in common. That leaves me with an x minus 3. Then you would divide by the x minus 3, which is right back to where we started. So there's a couple different methods you could take here. X squared equals 9. Regardless, what's really important here is that you realize that this one does have an extraneous solution. The positive 3 does not work because that gives me 0 in the denominator. So my only answer is negative 3. Okay, last one, and this one's pretty tricky of this. So first thing you're always going to have to do is you're going to factor all the bottoms. The reasons you're going to have to factor all the bottoms is because you have to check out all those domain restrictions. This is difference of 2 squares, so that's y minus 3 and y plus 3. All right? So now we can multiply to get rid of all these denominators. Let's go ahead and look at what our domain restrictions are going to be. Y cannot equal negative 3, so if I get that answer, I'm throwing it out. This one, it can't equal 0, or I'd throw that out. And here, it can't equal positive 3 either. So these are the answers that would give me extraneous solutions. So what am I going to multiply to get rid of the y plus 3? Well, I'm going to multiply by y plus 3. That will get rid of this first one. Now, what can I multiply by to get rid of the y? I'm going to multiply just by y. What about to get rid of a y minus 3 and a y plus 3? Well, I already have the y plus 3. So now I'm just going to multiply by y minus 3, and that will get rid of that as well. So everything has to be counted once, but nothing will be counted twice. So you divide by what's on bottom, you multiply by what's on top. So those y plus 3s here will cancel. And I'm left with a 6y and a y minus 3. What if you couldn't see it? Okay, so you multiply everything on top. That'd be 6y, y plus 3, y minus 3, and then you would divide by what's on bottom, that y plus 3, and those will cancel, and you're just left with what I wrote. Okay, on this one, the y's will cancel, and you just have a plus 2, and then you still have a y plus 3, y minus 3. On this last piece, the y plus 3 and y minus 3 will cancel, and you're just left with a y times the 5y minus 3. So let's clean that up a little bit. That's 6y squared minus 18y. This is y squared minus 9. It'll be easier to distribute to that. So that's plus 2y squared minus 18 equals 5y squared minus 3y. This is a little messy. Let's write it up over here. Erase my denominator. Okay. So 6y squared plus 2y squared, that's 8y squared minus 18y minus 18 equals 5y squared minus 3y. Looks like I'm going to get y squareds here. So let's get 0 on one side. Minus 5y squared. Add 3y. So I get 3y squared minus 15y minus 18 equals 0. Okay, now we're going to have to solve this. You can't get y by itself. It is not wrong for you to go ahead and start jumping into quadratic formula. But your life will be easier if you see that these all have a 3 in common. So that gives me a y squared minus 5y minus 6 equals 0. And what that allows me to do is factor. So I make your list for negative 6. 1 and negative 6 is what gives me negative 5. See, a whole bunch of you would want to use the 2 and the 3, but that would be 2 and negative 3. That gives me negative 1. I need the 1 and the negative 6. So y plus 1 and a y minus 6 equals 0, which means y equals negative 1 and y equals 6. Both of those are okay. This does get 2 answers. It didn't get that 3 that you thought you might get. Negative 1 and 6 will give us the answers here. Okay, so what happens if you have an equation that has radicals in it? Okay, it's tricky. You're going to actually, the strategy is going to be you have to square both sides to get rid of the square root, but you cannot do that until you isolate, get one of the square roots by itself. So I think I write that on the next slide. Let's double check. Yep, okay. So to solve a radical equation, you must first isolate the radical on one side of the equation. Then apply the principle of powers. You probably don't want to write that. Then square both sides, because that's probably what we're going to be doing. Now, sometimes there's going to be a radical equation that has 2 radicals, and that stinks. Okay, when there are 2 radicals, you have to isolate one, square both sides. Here, I'm going to erase that. Isolate one of them, square both sides. You're going to have to FOIL, and you're going to hate it. And then repeat the process, because you're going to get another square root. Okay, so let's look at these. You will need help on some of these homework problems, but the more you practice, the better you'll be. All right, so here's the first one. First ones are easy. This is not bad. Okay, so what kind of answer would be a domain restriction? Because we still have to check on these. Remember, 3x plus 1 is going to have to be greater than or equal to 0. So 3x is greater than or equal to negative 1. X is going to have to be greater than or equal to negative 1/3, or we're going to do something wrong here, I think. Actually, I don't know if the domain restrictions work out all the way times. These, I think, will be easier instead of doing that. Let's go ahead and just plug them in. Just plug in to check. And just be careful. Just be careful that this here, the square root, doesn't say that it equals a negative number, because that's going to be a big indicator that there will be an extraneous solution. Okay, this is great. The radical's already isolated. So all you have to do is square both sides. You're going to be like, this isn't even hard at all, Mrs. Bruno. And you're right. Sometimes they're really easy. 3x plus 1 equals 16. Solve it out. 3x equals 15 and x equals 5. Sometimes it's that easy. 3 times 5 is 16. 16 plus 1 is a square root of 4. Square root of 16. Does that equal 4? And the answer is yes. So that one works out perfect. Not bad at all. So what's all the fuss about? Well, let's look about this one. On this one, if you isolate the radical, means you'll have to subtract 4. And this is what I'm talking about. If you have the square root of y minus 1 equals negative 4, can that even be? Can the square root of anything equal negative 4? And the answer is no. This is going to have no solution. But a lot of you don't like to look at questions and think about them. Me neither. I'm not better than you. I would jump right into, ooh, let's square both sides. Okay. So y minus 1 is 16. Add 1. And y equals 17. And that doesn't work. Why doesn't it work? Because 17 minus 1 is 4. 17 minus 1 is 16. That's the square root of 16, which is 4. And 4 plus 4 does not equal 0. So this is called an extraneous solution. So you would throw it out. There's no solution. So really, it's not really the domain restriction that comes into play here. So I kind of misspoke before. It's more about what the radical equals on the other side of the equal sign. That has to follow the domain issues. So that one has no solution. How about this one? All right, what do I do here? Well, you isolate the radical, which I already kind of did for you by subtracting 5. Now we square both sides, and when you square both sides, you're going to have to FOIL. So those would cancel. That's x plus 7. This is going to be the same thing as x minus 5 times x minus 5. We've seen this a million times, so don't make that mistake. That's x plus 7 is x squared minus 10x plus 25. I have x squareds and x's. So we're going to have to get all of our x's on one side because you cannot get x by itself. So our strategy is going to switch. Our strategy is going to be to factor the quadratic formula or something of that nature. So that gives me x squared minus 11x plus, what's 25 minus 7? That's 18. And does that factor? Well, let's look. Make your list for 18. 1 and 18, not it. 2 and 9, yes, this will factor. So that should make you happy. We're going to have a negative 2 and negative 9 because I need the negative 11. So it's an x minus 2 and an x minus 9. Set each piece equal to 0 because that's what we're really doing there. And you get x equals 2 and x equals 9. Now we're going to check to make sure it's even going to work out for us. Okay, what if x equals 2? Well, that'd be 5 plus the square root of 9. Does that equal 2? Does 5 plus 3 equal 2? No, it doesn't. 2 is not an answer. Really have to check on these guys. How about 9? 5 plus the square root of 16, does that equal 9? 5 plus 4 does equal 9, correct. So that answer is x equals 9. All right, this one. This is the ones that make you want to cry. Okay, so do you see how there's two radicals here? So you can only get rid of one at a time, which means you're going to have to isolate one and then square both sides. And that's going to be really tricky for some of you. You might need a little help. So when you square the square root here, you get an x minus 3. On the second one, what you get is 4 minus the square root of x plus 5 times 4 minus the square root of x plus 5. Okay, x minus 3 is good to go, but here's where it gets tricky. 4 times 4 is 16. Now look, I have minus 4x plus 5, and then I get it again. Minus 4 square root of x plus 5. That's the hard part. The last part's not so easy. A minus and a minus is a plus. And then this is the same thing as the square root of x plus 5 times the square root of x plus 5, which is the square root of x plus 5 squared, which basically the last one gets rid of the square roots and you're just left with the underneath. Okay, so let's clean this up. That's x minus 3. 16 plus 5, that's 21. Then I have the plus x, and now I have minus 8 square root of x plus 5 because those are like terms. Okay, now we got to isolate this radical. So first you'll subtract 21. Then you'll subtract x. That should make you happy because those drop out. So it's negative 24 is negative 8 square root of x plus 5. You got to isolate the radical all the way. So you divide by negative 8 here. And you get 3 equals the square root of x plus 5. And that's very manageable. So the last step's not hard. Back to what we were looking at, those level 1 problems. That's 9 is x plus 5. Minus 5 minus 5, and the answer is 4. You do have to check to make sure it will work out. 4 minus 3 is the square root of 1. That's 1. Plus 4 plus 5, that's the square root of 9. That's 3. Does that equal 4? And the answer is yes. So all that work to get the 4. So what we're going to do is you isolate one, you FOIL, it's nasty, isolate the other, and you'll get an easier problem. And that's as hard as it will get today. Okay, you're going to work on that test review and you're going to ask some questions. You might have to set up some Google Meets, like I said. Make sure you ask the questions when you have them.